Hi, this is Rebecca Sager. This is my NCTM article share for week 12-16. It's called When the Answer is the Question. This particular article has to do with elementary students and division problems that have remainders, and getting students to understand what the remainder means. So if I have 34 donuts and a box can hold 8 donuts, how many boxes am I going to need? And the students say, oh, well, that's easy. It's 4 remainder 2. They don't understand what the remainder means. So the teachers got together and decided to have the students start posing their own problems. And they did it in reverse. They gave them the answers. And they wanted them to write 4 different word problems for 46 divided by 4, in which you could have multiple different answers. So the students were asked to solve this for 20 minutes independently. And the poor students, you can see some of them put their heads down in frustration. Some said, do I have to do this? Why aren't there questions already written? And after 20 minutes, the students were then put into cooperative groups to discuss what they'd come up with. Given time, it was evident that only one group had one student who was able to get a word problem for multiple answers. And so after time, they decided, that the struggle was no longer productive, so they decided to give more scaffolding. So the next day, the students were given this problem, same numbers, 46 and 4, and asking them to get together and talk about what they could come up with. And the students again were given 20 minutes to pose different problems, but this time start cooperatively. And once the students started to discuss it and talk about what was realistic and what was real world, they began to realize that, you can't have 2 extra footballs as a remainder and divide those 2 extra footballs up among 4 friends. But as this student was noticing, if I change that from footballs into food, I can do that because I can split food, but you can't split footballs. So the article was talking about connecting real-world situations prepares the students to use math on a day-to-day basis, and posing problems helps struggling students solve word problems for which they had to interpret the remainders. So in using this idea in my classroom, we are working on the differences and similarities of covalent and ionic chemical bonds. The process of bonding is conceptually mathematical because the students have to share, give, and take valence electrons to create a full outer shell of 2 or 8, and ultimately create a neutral charge when the charges of the different atoms are added up. There's so many complex parts and pieces and processes of this, but the students are definitely willing to struggle through it in class with me and with each other. I employ the think, pair, share strategy often, and I ask for spokespersons and volunteers to come to the board to work out problems. The students know that when they make a mistake, I'm going to thank them for bringing up a misconception that others are struggling with as well, and walk them through the how and why that the misconception can be fixed. These students have been working on understanding the everyday context of ionic and covalent compounds. And this article is something that just reinforced the idea that it's okay for the students to struggle productively, and it's okay for me to do reflective teaching as well. This article talked about reflective teaching, a process of self-observation and self-evaluation, and looking at your classroom practice, thinking about what you do and why you're doing it, and then evaluating whether it works. I have to do that frequently with higher level thinking skills associated with ionic and covalent bonding. But it seems like that process has solidified for the kids, and they understand and know that they're not going to be penalized for making mistakes, and that we will all work on it together and continue to productively struggle. I hope you enjoyed the article. I sure did. Thank you very much.